Here we're going to talk about pseudo force. What is pseudo force? Let us take some example to understand this pseudo force. See, he's standing on the truck. Now the truck is moving with some acceleration. Now in what direction is he moving? It appears as if he is moving in the backward direction for an observer in the truck. If you observe this situation from the frame of reference of the truck, it appears as though he is moving in the backward direction. But actually, he is not moving in the backward direction. He is moving in the forward direction, or he is at rest. Definitely not in the opposite direction. But for an observer in the truck, it appears as though he is moving in the backward direction, right? So he assumes that, the observer assumes that there must be some force acting on him in the backward direction, because the observer believes that that person is moving in this direction, so there must be some force. Otherwise, it would be a violation of Newton's law. What is Newton's law? The observer was initially at rest, so he is moving in this direction now, so there must be some force acting on him in this direction. But actually, there is no movement in this direction, so there is no force in this direction, but it appears for that person that there must be some force in this direction. In fact, it is the absence of friction between him and the truck that makes him appear to move in this direction. See, if there was enough friction between him and the truck, he will move in the forward direction. The friction will take him in this direction. Because there was not enough friction between him and the truck, so he is not moving. Then it appears as if he is moving in the opposite direction, right? So the observer believes that the person is moving in this direction. So there must be some force in this direction. So this is an imaginary force, right? For that moving observer, it appears as though there is a force in this direction. This imaginary force is what is called the pseudo force, right? So let us understand this better by taking another example. Here he is observing this truck from an inertial frame of reference. So the observer is not moving. Observer is at rest. Now the truck is moving with some acceleration, but the lamppost is at rest. Now he gets onto the truck. Now he is also moving along with the truck. Now for him, the truck appears to be at rest, because he is also moving with the truck, so the truck appears to be at rest. But for him, this lamppost seems to be moving in the opposite direction. So actually he is only moving, but for him the lamppost appears to be moving in the opposite direction. So he assumes that there must be some force acting on the lamppost in the opposite direction, because the lamppost is moving with some acceleration for him. So he believes that there is some force acting on the lamppost in the opposite direction. So this imaginary force is what is called a pseudo force. So because this time the observer is also moving with some acceleration, so the pseudo force is acting on the other object in the opposite direction. Okay, so let us take this example. Here we have a frame of reference which is inertial. Okay, it is not moving with some acceleration. So this person is observing that block from this frame of reference. That block is at rest. So no force is acting on that block, right? Now he is observing the same block from a different frame of reference which is moving now with some acceleration. Now for him, it appears as if this block is moving in the downward direction. So that means he assumes that there is some force acting on this block in the downward direction. Actually, this block is not moving. So no force is acting on the block, but for him it appears to be moving in the downward direction. So he assumes that there is some force acting on this block in the downward direction, but actually he is only moving with some acceleration, but he thinks that this block is moving with the acceleration in the opposite direction. So he assumes that there is some force acting on this block in the opposite direction. So that assumed force is what is called a pseudo force, right? We'll derive some formula for this pseudo force whenever the observer is in a non-inertial frame of reference. Alright, yes. Now here the acceleration of that block with respect to that person, right, moving with some acceleration. So what is that acceleration? Let us take that to be, say, A is the acceleration of that block P. The block is P. So acceleration of the block P with respect to that new frame of reference that is taken as S dash. So this is S, so S dash. This means A P S dash. So that is the acceleration of that block P with respect to S dash. Okay, that is equal to, we are just using the concept of relative acceleration. What is relative acceleration? The actual acceleration. What is actual acceleration? The acceleration of P with respect to S. Okay, S is the inertial frame. So if you observe from that frame, so we will understand the actual motion of the object, which means the object has the actual acceleration. Maybe here the block is not moving, even if it is moving with some acceleration, so that acceleration can be observed only from that non-inertial frame of reference. But for non-inertial frame of reference, the actual acceleration minus the acceleration of that moving frame of reference. That is the formula for relative acceleration, right? So what you have to do, from the actual acceleration we have to subtract the acceleration of the observer. So that is the formula for relative acceleration. So that's it. Now simply multiply this by m. M is the mass of the object. M a p s dash equals m a p s minus m a s dash s. Now what is m multiplied by acceleration? That is the force, right? Force equal to mass times the acceleration. So mass times acceleration, that is the force as observed by the person in that moving frame of reference. That means you denote that by s dash. So what is this? This is the force acting on that block if you observe it from that moving frame of reference. Okay, so that equals, this is again mass times acceleration, but it is from the frame s. So that means that is the actual force acting on the block, right? Fs, that's all. But these two are not equal because we have some term here. So m multiplied by acceleration of s dash s. So the actual force is not what is observed by that person from the moving frame of reference. So there is some extra term. So this extra term is what is called by the name the pseudo force, right? So the pseudo force is the extra term added with the actual force. Okay, so that gives you the observation, right? So the force as observed by that person. Okay, so this is called a pseudo force. Okay, just remember this formula. Okay, so what is the formula for pseudo force? That equals, use this formula, mass of the object. Okay, mass of the object, okay, multiplied by a s dash s. What is s dash s? That is the acceleration of the observer, right? The observer is moving with the acceleration this. So mass of the object should be multiplied by the acceleration of the observer. This time the observer is moving, so the acceleration of that person. So that is the formula for pseudo force that you have to remember. Alright, so this is the formula. Okay, so you have to remember, whenever the observer is not in a inertial frame of reference, the observer himself is accelerating, so then you have to use this extra force called pseudo force, which has formula mass of the object multiplied by the acceleration of the observer. Okay, but what is the direction of this pseudo force? Okay, so the direction of this pseudo force, right, from that expression we can understand that the direction of the pseudo force is minus, right? That means opposite to the direction of that observer. Okay, observer is moving in one direction, so that block appears to be moving in the opposite direction. So that means, so the direction of pseudo force is opposite to the direction of the observer. Okay, so that's also, these are the 2 points that you have to remember about pseudo force. Alright, so what are the things you have to know about pseudo force? When the observer is not in an inertial frame of reference, he is moving with some acceleration, then along with the other forces acting on the object, you also have to include this pseudo force. Okay, what is pseudo force? So that has formula mass of the object, means the object that is observed, right? So mass of the object multiplied by acceleration of the observer, not acceleration of the object. Mass of the object multiplied by the acceleration of the observer. Okay, and the direction of pseudo force is negative, right, in the opposite direction to the direction of acceleration of the observer. Alright, so these are the only points you have to know about pseudo force. So let us do some simple questions based on this pseudo force to understand the concept better, right? Yeah. Here a pendulum is suspended at the ceiling of a moving car moving with some acceleration. Now this pendulum will not remain vertical, so it is deviated from the vertical position. It makes some angle with the vertical, so that angle is what we need to find. Suppose the car is moving with a constant speed, no acceleration, or the car is at rest. In any case, this pendulum will not deviate, it will remain vertical. But when the car is moving with some acceleration, only then there is a deviation. So that deviation is what we need to find, the angle. We can do this question by two methods. You can observe this from an outside, right, frame of reference, right? You can observe this situation from outside, or you can observe this in the frame of reference of the car itself. Okay, so if you observe this from the frame of reference of the car, then you are in a non-inertial frame. So that means you have to use pseudo force, because when the observer is in the non-inertial frame of reference, so there is a pseudo force along with the other forces. Okay, so if you observe from outside, then there is no pseudo force because the observer is at rest. Okay, let us do it by both the methods. Okay, see, observer is outside, so this is one of the methods. Okay, the observer is outside, which means the observer is in inertial frame of reference, no need of pseudo force. Let us consider all the forces acting on this pendulum. Okay, what are the forces acting on this? So it is deviated like this. Now there is a tension force acting in this direction, and vertically downward gravitational force. You have to take the horizontal direction. What are the forces acting in the horizontal direction? You have to take all components. Suppose the angle is theta. Okay, that means what is the tension force acting in this direction? So that is, so what are the forces in the horizontal direction? What are the forces acting in the horizontal direction? So that is the component of the tension. Okay, component of tension in the horizontal direction. So that the angle is theta, that means this angle is 90 minus theta, so t sin theta. Okay, so that is t sin theta. So t sin theta, so that is the only force acting on the pendulum, okay, in the horizontal direction. No other force, right? Because the other force is vertically downward gravitation force only. T sin theta is the horizontal force. Okay, so what is the horizontal acceleration? That is same as the acceleration of the car only. So that means, so that is m multiplied by a0. So that is the acceleration, because total force equals mass times the acceleration. Now we'll also consider the vertical motion. In the vertical direction, there is no motion in the vertical direction. So total force must be 0. What are the forces? The component of tension in the upward direction. Similarly, downward weight. So what is the component? So that is same theta angle. That means t cos theta. T cos theta in the upward direction. Okay, t cos theta. That must be equal to the downward weight force, right? So what is the gravitational force? M multiplied by the, mg, right? So m multiplied by g. So that's it. So now you can just divide. We don't want tension. So sin theta divided by cos theta. So that equals tan theta. So tan theta equals, so this is what? A0 divided by g. So that's all. So that is the required angle, right? If you want, you can write theta as tan inverse of A0 divided by g. That's all. So this is the angle made by the pendulum with the vertical when the acceleration is A0. That's all. Okay, done. Okay, now the same question can also be done from that frame of reference, right? Frame of reference of the car, right? So observer is inside the car. When the observer is inside the car, then the observer is in the non-inertial frame of reference. You have to consider pseudo force also. But when the observer is inside the car, there is no acceleration. The pendulum seems to be at rest, because for an observer inside the car, the pendulum seems to be at rest. That means total force must be 0. But what is the total force? So in the horizontal direction, what is the total force in the horizontal direction? So the component of tension, okay, so that is in this direction. Tension is in this direction. So component of tension, take this one, t sin theta. What are the other forces? We have to consider this time pseudo force also, because the observer is moving with some acceleration. Observer is moving in this direction with acceleration a0. That means the pseudo force must be in the opposite direction. So we know that the magnitude of pseudo force is mass of the object multiplied by the acceleration of the observer. The magnitude. Then the direction is opposite to the direction of motion of the observer. Observer is moving in this direction, so the pseudo force will be in the opposite direction. That means minus mass of the object multiplied by the acceleration of the observer. So a0. This is the total force acting on this pendulum. So according to that observer, okay, that observer is moving, but that must be equal to 0 this time, okay, because for him the pendulum is at rest. Okay, that is horizontal. Then we can also take vertical. Vertical, there is no difference, right? Same thing. So only force is in the vertical direction, that is, gravitational force and also the component of the tension force. So t cos theta is equal to mg. That's all. So if you solve this, you will get the value. Same thing. Tan theta is equal to a0 divided by g. So that's also same answer we will get. See, Actually there is no difference between this method and this method. That's all. See, same thing here. You see t sin theta equal to mass times the acceleration. But here, because the acceleration is a0, for an observer outside, the pendulum is moving with some acceleration. For an observer inside, the pendulum is at rest. That means total force is 0. Okay, the acceleration is 0. So this term, instead of here, we have used that term here. That is the only difference. So you can consider this as a pseudo force, or that is the total mass times the acceleration, total force. So it doesn't matter. That depends on the perspective. Okay, the observer is outside, it appears to be the acceleration. For observer inside, it appears to be a pseudo force in the opposite direction. So in any case, we'll get the answer. See, for this question, it is optional, so we don't need to consider pseudo force, right? You can simply use our basic idea to solve this question. Okay, but in some questions, it is very important to use pseudo force. Without pseudo force, it gets very complicated. So it's not that we can do away with pseudo force like this. Okay, this method is relatively easier compared to this, but still you have to know what pseudo force is, because for some questions it is very important to use pseudo force, otherwise it gets more complicated. Okay, so that's all. So for this question, the answer is this one, tan inverse of a0 divided by g. That's all, right? So here mass times the acceleration, but in this case this same expression here is called by the name pseudo force. That's all. Okay, so along with the other forces, the pseudo force also acts in the second case. Okay, so the answer is a0 by g. Okay. This question is same as the last question, except that the car is moving on an inclined plane, not on a horizontal surface, but the idea is same, right? Here we will only observe this from the frame of reference of the car. That means it is an accelerating frame. You have to consider the pseudo force also. Alright, yes, let us consider all the forces acting on the pendulum in the frame of reference of the car, right? Yes. Now in the frame of the car, right? In the car frame, okay, let's call it car frame. That means you are observing this from the car, right? So which means the observer is accelerating. Now tell me, what are the forces acting on the pendulum in the normal direction? Let's consider the normal direction. What are the forces acting on this pendulum in the normal direction? So this pendulum is making some angle theta with the ceiling, right? That means in the direction of the incline. So that means its normal component of the tension. Tension is acting in this direction. Its normal component is t sin theta, because theta, this is 90 minus t sin theta. So t sin theta in the upward direction. In the downward direction, we have the component of the gravitation force. Gravitation force is mg in the downward direction. So that angle is phi only, phi, mg cos phi, okay, minus mg cos phi, minus mg cos phi, that is the component of the gravitation force, that is 0, because the acceleration in the normal direction is 0, because the object is moving in this direction, the normal acceleration is 0, so that is in the normal direction. Now we will consider the forces along the plane. So what are the forces acting along the plane? Okay, along the plane, that is the component of the tension force. Tension force in this direction, component of tension, so same theta, right? That means t cos theta, so t cos theta. And also the component of the gravitation force, right? Gravitation force in the downward direction, so we have to take its component also. So 90 minus phi, so mg sin phi, okay, minus opposite direction, minus mg sin phi. Okay, now we also have to consider the pseudo force, right? Because it is the accelerating frame. What is pseudo force? Mass multiplied by the acceleration of the observer. Observer is the car only, so that has acceleration a0. That means mass of the pendulum, that is m, multiplied by the acceleration of the observer, that is a0. Okay, but what is the direction? See, the acceleration of the observer is in this direction. Then the pseudo force will be in the opposite direction, so negative, okay, minus. So this is the pseudo force here, so that must be equal to 0, right? Because if you observe this pendulum from the car, it appears as though this pendulum is at rest, so 0. Okay, that's all. So we have to simply solve this to get the answer. So you can divide this, sin theta divided by cos theta, so that is tan theta. Okay, so you can take all these terms to the other side and divide, that's it. So sin theta divided by cos theta, that equal to mg cos phi, mg cos phi divided by, so this one, mg sin phi, and then m a0. That's also, that is the answer. Or we can write, I think we can divide by m. So we will get g cos phi divided by g sin phi plus a0. That's also, this is the angle made by the pendulum with that ceiling, right, with the inclined plane, okay, not with the vertical. So that as formula tan theta g cos phi divided by g sin phi plus a0. Alright, so that is the answer to the question. Here an elevator is moving up with some acceleration a0, a bolt in the ceiling has broken off and we have to find the time taken by the bolt to reach the floor. Okay, yes. Now here this question can be done simply by using the relative acceleration. We don't need to use the concept of pseudo force, right? But now that we have done pseudo force, let's make use of this, right? Now we observe this in the frame of reference of the elevator. That means we observe from inside the elevator. That means, so we have to consider the pseudo force also, because the observer is now accelerating. So we have to consider pseudo force also. Now in the elevator frame, okay. So now the frame of reference is accelerating. So that means, what is the total force acting on this object? So one force is the weight force, right? The gravitation force is acting in the downward direction, mg. Now not only this, we have to consider the pseudo force also, because the observer is moving with some acceleration. So what is the formula for pseudo force? Mass of the object, so that is same m only. So mass of the object multiplied by the acceleration of the observer. Observer is moving up with acceleration a0, so mass of the object multiplied by the acceleration of the observer. Okay, done. Now what is the direction? So here the observer is moving in the upward direction. That means the pseudo force will be in the opposite direction, so minus you have to take, right? So mg, now plus, because mg we have taken downward direction, so pseudo force is also in the downward direction, because observer is in one direction, pseudo force will be in the opposite direction. So that means this is plus. Is that okay? So that's all. So that is the total force acting on that bolt here. Now this is force. That means, what is the total acceleration of the bolts? That is divided by m. That's all. So this is g plus a0. That's all. This is the acceleration of the bolt. Acceleration is known. We have to find the time taken to cover the distance of, say, L. Alright, so L is the distance, height of the elevator. So what is the formula? So we can use simply this formula, S equals ut plus half a t square. That's all. S is the total distance covered. L, see, that is the relative distance, right? So this is u initial speed, that is 0, plus half the acceleration of the object, so that we have found here, so that is g plus a0 multiplied by t square. That's all. From this we can find the value of t. So t is simply, so if you multiply, that is 2l divided by g plus a0, that is the value of t square. So we have to take the square root to find the value of t. So that's all. So that is the time taken. You understand? It's simply the concept of relative acceleration. Okay, so this is the relative acceleration. That's all. So we've simply used it. But now we've got it from the pseudo force. We can directly write the relative acceleration also without using any pseudo force idea. But it's the same idea, right? Essentially. Okay. So anyway, so the total distance or the time taken by the bolt to reach that floor. So that is 2l by g plus a0 under root. Okay. So that is the answer. Here also we have an elevator which is moving downwards with some acceleration. We have to find that acceleration when this block placed over this wedge is not sliding. No relative motion between this wedge and this block, right? So that acceleration we have to find. And in the next case, so this time the elevator is moving with the half of the initial acceleration, right? So in that case we have to find the time taken by that block to reach the bottom of the wedge. Alright, yes. Now first of all, we will find the acceleration when this block is in equilibrium with respect to the wedge. Okay, yes. So in the elevator frame again. So first of all, equilibrium. So that is the first case, right? Equilibrium means what? With respect to that elevator, right? So if you observe this in the frame of reference of the elevator, this block is in equilibrium. So that means the forces balance each other. What are the forces acting on the block? In the frame of reference of the elevator, which is moving downwards with some acceleration. Okay, so that means along with the gravitational force, what are the forces acting on this object? M multiplied by the G value, right? Mg is in the downward direction, but the elevator is moving in the downward direction with some acceleration. That means we have a pseudo force. What is that pseudo force here? The mass multiplied by the acceleration, but in the opposite direction. Elevator moving in the downward direction. That means the pseudo force will be in the opposite direction. So minus m multiplied by a0. So that must be equal to 0 because it is in equilibrium with respect to the elevator. So that means, so we are getting the acceleration. So that is a0. So the acceleration, the initial acceleration, okay, g. Right, that is very obvious, right? So if the elevator is moving down with the same acceleration, right, that object is already moving with the it has the downward force, right, the gravitation force. So these two forces balance each other. So same acceleration as the acceleration due to gravity, then this object looks as if it is not moving. Okay, yes, now that is done. Now the second case, we have the acceleration, half of this acceleration. Okay, so when the acceleration is, so this time when the acceleration is half of this, a0 by 2. So that means here in this case it is g by 2. So that's also g by 2 is the acceleration of the elevator now. Now we have to find the time taken by that block to reach the bottom. That means it has to cover certain distance. Alright, yes, let us find the total forces acting on this object. Okay, yes. So what are the forces acting on this block? Along the inclined plane. Okay, so that means along the inclined plane we have the component of the gravitational force in that direction. Okay, so that is mg. Okay, mg is the downward direction. You have to take the component along the plane. Okay, so that is mg sine theta, because theta 90 minus theta, so sine theta we have to do. So sine theta. Not only that, we have the upward pseudo force, right, because again it is accelerated, right, so it means upward pseudo force. So we have to take the component of the upward pseudo force in the direction of the plane. Okay, so what is that? So that also 90 minus theta, right, that means the upward force is minus m, this is the acceleration, ma, okay, multiplied by, you have to take the component, so that is sine theta, right, so sine theta. So this is the total force acting on the block when you observe this in the elevator frame, right, which means in the accelerated frame of reference. Okay, ma sine theta, that is the total force. So that must be equal to mass times the acceleration. Now, okay, we can call it, say, a1. So a1 is the acceleration of the block in the second case with respect to that elevator, right? Yes, now, so we got the acceleration. Now we have to find the time taken, right? Because again the distance is known, we have to find the time taken using the same formula that we used in the last case. So what do you get here? So this gives you the acceleration a1, so that equals, so m can be divided, so g sine theta, so g minus a sine theta. Okay, so that's it. But a is already known, right? What is the value of a? G by 2. So that means g minus g by 2. So that is g by 2 sine theta. So we've got the acceleration. So let us use the same formula again. So what is that? S equals ut plus half at square. But a here is a1, right? So a1 only. So that means, so the distance to be covered is L. L divided equal to 0 plus initial speed 0, 1 by 2. This a1. So a1 is this one. So g by 2 sine theta multiplied by t square. Okay, so that is done. So from this you have to just find the value of t, that's it. So this gives you the value of t, so that equals, if you multiply 4l divided by g sine theta, okay, so root. So that's all. So that is the answer. So square root of 4l divided by g sine theta. So that is the time taken by the block to reach the bottom. Alright, yes, simple. See, in the first case it is in equilibrium, not absolute equilibrium, equilibrium with respect to that elevator frame, right? If you are observing the system in the elevator frame, it is in equilibrium, right? Yes, this means it is not sliding. In that case, we got the acceleration, so that is same as the acceleration due to gravity. Okay, now in the second case, we got half of the acceleration. The elevator is moving this time with half the acceleration, that means g by 2. So after that you have to use the same idea, the forces acting on the block, but the forces acting on the block include that pseudo force also, right? Because again we are observing from the elevator frame of reference, so pseudo force also is considered. So you got the acceleration. Once acceleration is known, we can find the time taken because distance is known. Acceleration is known, we can find the time taken, right? So that is the answer. Again, we have an elevator inside which we have two blocks connected by a string, and this upper block is connected to the ceiling by a spring. We have to find the elongation in the string when this elevator is moving up with acceleration a0. Alright, so same thing, we have to consider all the forces acting on these two blocks. Alright, so the first block, say M. So this is the upper block, so this is block M. So what are the forces acting on this block? So that is mg in the downward direction, right? So mg. And then the tension force, right? Tension in the string, that is also acting in the downward direction, right? Tension, so plus T. And also the spring force in the upward direction, right? Minus Kx. So that Kx is the elongation, so Kx. These are the forces acting on that block. But we are observing this in the elevator frame. That means the observer is moving up with some acceleration, a0. That means we have to consider pseudo force also, because the observer is accelerating. Now, what is the pseudo force? The observer is moving up with acceleration a0. That means the pseudo force will be in the opposite direction, right? Downward. Downward direction is taken to be positive, which means plus. So plus the mass of the object. So the mass of the object is small m multiplied by the acceleration of the observer, right? What is the acceleration? That is a0. This is the total, that must be equal to 0, because see, it is at rest, right? In equilibrium. When you are inside that elevator, right? So that's all. So this is for that upper block. Now similarly the next block. So for the block capital M, so what are the forces acting on that block? So same thing, the gravitational force in the downward direction, so mg, and then the tension force is acting in the upward direction, so minus T. Okay, so that's all. These are the forces. Now we have to consider pseudo force also. Now same pseudo force, right? But this time the mass of the object is capital M, not small m, for the second object. So that means plus capital M multiplied by same acceleration of the observer, that is a0. So that is also 0. Okay, that's all right. So we have to simply solve this to get the value of yeah. So let us find we can just add these two. Okay, so to eliminate this T, so we want to find x value, right? So we just add these two. So this gives you, if you add these two, we'll get m plus m multiplied by g, and then minus kx, or plus, you can take a0 out, so you'll get m plus m a0, so that equals kx. Okay, so taken to the other side, that's all. We'll get the value of x from this. So the required value of x here is, you can take out again m plus m, so m plus m multiplied by g plus a0, so that's all, divided by this k. So that is the answer, right? So that is the elongation in the spring. Okay, that's it. See, so this is very obvious, right? Because if this a0 is 0, so that means the elevator is at rest. Then what will be the answer? M plus n g equal to kx, because you can consider these two blocks to be one system. So the total mass is m plus mg in the downward direction, right? Total force on the object. The opposite force is kx. So kx should balance m plus mg. So m plus mg equal to kx. Then x can be found divided by k. But because this acceleration a0, instead of the acceleration g, we have this acceleration g plus a0. You understand? That is just like the relative acceleration only. Alright? Yes, that's all. So anyway, the answer is this one, simply m plus m g plus a0 divided by k. Okay. Here we have two blocks A and B having equal mass m. They are connected by a string, and this system is placed over another bigger block. We can call it wedge. A force F is acting on this wedge. We have to find the force F for which these two blocks are in equilibrium with respect to that wedge. They are not in equilibrium actually, they are also moving, but with respect to that wedge they are in equilibrium. That means they are not sliding over that wedge. Okay, we have to find that force. So obviously we need to observe this in the frame of reference of that wedge only. That means it is an accelerating frame of reference. So we have to use pseudo force also. Yes. Now first of all, let us find the acceleration of that wedge. Okay. Yes. The force F is acting on the wedge. Now we will not consider that wedge. You will consider the total as a system. These two blocks and the wedge as one system. Okay. So the blocks and wedge together. Blocks and the wedge. What are the forces acting on this system in the horizontal direction? The only force acting is the force F. So that is the only force. So force F. Okay, in the horizontal direction. So that equals mass times the acceleration. So what is the mass of the object? So that is mass of one of the blocks, mass of the other block, and the mass of that bigger wedge. So that is 3m. This is a total mass multiplied by the acceleration. Let's call it say A0. So that is the acceleration. Okay, so that will give you our required force. So means the acceleration. What we need is the acceleration. So A0. So that equals the force divided by 5m. So we got the acceleration of the wedge. That means the acceleration of the observer. We need that for finding the pseudo force, right? So acceleration of the observer found. Now we will consider these blocks one by one. So the block A first. Okay, block A. What are the forces acting on this block A in the direction of that string? Okay, so that means in this direction, right? Inclined at some angle, say 30 degree. So what are the forces acting on this block? Mg in the downward direction, we have to take its component, right? Mg, the component of that. So what is that? So Mg, that angle is, this is 30 degree, that means that is 60 degree. Mg cos 60 or sin 30, right? So Mg sin 30, that is the component of the gravitational force in the required direction. Okay, and in the upward direction we have the tension force, so minus T. So we take in the downward direction positive, so minus T in the upward direction. Not only that, we also have the pseudo force because we are in the accelerating frame of reference. Okay, so what is pseudo force? Acting in this direction, so that has formula, the pseudo force, so in this direction, right, opposite, so minus m a 0. Okay, yes. Now we have to take its component because pseudo force is in this direction, because the acceleration of the observer is in this direction, so pseudo force will be in the opposite direction, right? So this direction, but we have to take the component in our required direction along that string. So that means you have to take that angle. So what is that angle? That angle is 30 degree only, same angle, right? Corresponding angle 30 degree. So pseudo force is m a0 in this direction. Take its component cos of 30 degree, right? So multiplied by cos. This is the total force acting on the block A. So that must be equal to 0. 0 because it is at rest with respect to that wedge. Okay, so that's all. So that is one of the equations. Now similarly we will find the same thing for the block B. What are the forces acting on the block B? Of course the tension force is acting in this direction. No gravitational force, right? That is in the perpendicular direction. So the tension force T. And also the pseudo force in the opposite direction, because correct, same force m a0, right, in the opposite direction. Yes, so minus, okay, m multiplied by a0, that is the pseudo force. So that must be equal to 0 because again it is at rest with respect to that observer. Okay, so that's all. Now we have to simply solve these to get our required answer. Alright, so this implies, what is the value? So if you add these two, T gets cancelled, mg multiplied by sin 30. So that can be written as mg multiplied by 1 by 2. Okay, sin 30 is 1 by 2. Okay, so that T gets cancelled, m a0. Alright, so if you take it to the other side, so we'll take out common factor, m a0 if you take out, so 1 plus cos 30. Cos 30 is root 3 divided by 2. Okay. So that's all. Now we've got this a0 already, right? So here we found it. So that can be substituted there. So this m gets cancelled. So we get g divided by 2 equals, this a0 value is f divided by 5m multiplied by, so this value is 2 plus root 3 divided by 2. So that's also, this will give you our required force F. So F equals, so what is that value? So this 2 gets cancelled. So this is equal to mg, okay, 5 mg divided by, this is 2 plus root 3 So that's all. So that is the required force, right? If this is the magnitude of that force acting on the wedge, then these two blocks will not slide. What if this force exceeds this limit? If the force is more than this force, that block B will move in this direction, right? Opposite direction. Okay, yes. Now if the force is less than that, maybe this block A will slide down. Okay, so these are possibilities, right? Depending upon the force F, maybe the block B moves in this direction or in this direction, right? The block A may slide down or it can move up also. It depends. But exactly when F is equal to this, then these two are in equilibrium with respect to that wedge. Alright, so that means, so that is the answer, 5 mg divided by 2 plus root 3. Here we have a block placed over a wedge which can slide along the incline. Now this wedge is free to move in the horizontal direction. As this block slides along the incline, this wedge will also move in the horizontal direction, right? So the acceleration of that wedge is what we need to find. See, now we have to observe this in the frame of reference of the wedge. Okay, the observer is on the wedge now, but we don't know the acceleration of the wedge, right? So we take it as some a0, right? That is the acceleration of the wedge. So we have to consider the pseudo force also for finding the acceleration of that block. Okay, because the observer is now accelerated, right? Yes. Now let us find. So what are the forces acting on the block? This wedge is moving in the horizontal direction, this direction, with acceleration say a0. Okay, done. Now what are the forces acting on that block? See, there is a normal force between these two surfaces, right? Normal force. So N is a normal force, and downward we have the gravitational force. Okay, now in addition to this, we also have the pseudo force. What is pseudo force? This observer, that means the wedge, is moving in this direction, a0 acceleration. That means there is pseudo force in the opposite direction, right? The mass of the object, the block, is m multiplied by the acceleration of the observer. M a0 is the pseudo force acting on this block in this direction. So let us consider all these forces. All right, first of all, so we are considering in the frame of the wedge, which means we are observing from the wedge. Okay, now that means having acceleration some a0 is the acceleration of the wedge in this direction. Okay, yes, so that means we have to consider the pseudo force also for that block. Now for the block M, so what are the forces acting on the block M in the normal direction? So we will consider the normal direction, normal to that incline. So what are the forces? The force N, the normal between these two surfaces, N is acting in that direction, and also the component of the gravitational force in that normal direction, opposite direction, right? So mg in the downward direction, so its component, if you take that angle, is theta only, right? So mg makes angle theta with the normal, so mg cos theta, right? Yes, so that means N minus mg cos theta. So this is the gravitational force component. Now we also have that pseudo force. What is pseudo force? That is m a0 in this direction, right? So m a0, so that is in the direction of normal, so it is m a0, but you have to take its component because we are finding forces in the direction of normal. M a0, that angle is 90 minus theta, okay, with the normal. So m a0 sin theta, because 90 minus theta sin theta, so m a0 sin theta, that equals 0 because this block is not moving in the normal direction because we are in the frame of that wedge. So that means in the normal direction there is no motion, it is only sliding along that incline. So that means this is that is equal to 0 acceleration in the normal direction. Okay, done. Now similarly we have to consider the next object, that is wedge. What are the forces acting on the wedge? See, the wedge is moving in the horizontal direction. Let us take the component of the normal force. The only force acting on this wedge in the horizontal direction is the normal force, its component, right? Normal in this direction, so take its component. This angle is with the horizontal is 90 minus theta, so n cos 90 minus theta or n sin theta, right? So that is n sin theta. That is the only force acting on this wedge in the horizontal direction. See, we can either consider the forces from the frame of reference of the wedge itself, or we can observe it from outside. Okay, doesn't matter, we will observe this from outside. That means the wedge is moving with acceleration a0, same acceleration a0. So that means this is the total force, that must be equal to mass times the acceleration, but mass is 2m multiplied by the acceleration is a0, we have already taken that. Okay, so that's all. So these are the two equations. Solving them, we should be able to get the value of A0, right? That's what we want, the acceleration of the wedge. So let us substitute this n here. What is the value of n? So that you can substitute here. So from this equation, so that gives you, what is n? N is 2m A0 divided by sine theta. Okay, and then from this minus mg cos theta plus m A0 sine theta. So that equals 0. Okay, now A0 we can take out. Okay, as a common factor. M can be cancelled, right? So m can be divided. Now we can take A0 out. So we'll get 2 divided by sine theta, and there we get sine theta. That equals, this is g cos theta. G cos theta. So that's it. So we will get our required acceleration A0. So that equals, if you cross multiply, this is g sine theta cos theta divided by this one. So 2 plus sine square theta. Okay, so 2 plus sine square theta. So that's all. That is the required value of A0, which is the acceleration of the wedge. Okay, so that is the answer, g sine theta cos theta divided by 2 plus sine square theta. Okay. Here the force F acts on the bigger block, and the frictional force between these two blocks is what is preventing the smaller block from sliding down. Alright, yes, we have to find the force F for this to happen, right? So we want the block, smaller block, to be in equilibrium with respect to the bigger block, right? It is not in equilibrium, it is moving along with that bigger block, but with respect to that bigger block, right? So if the observer is on the bigger block, then that smaller block seems to be in equilibrium, right? That means we have to observe this system from the frame of reference of that block of mass capital M. That means it is the acceleration, the observer is in accelerating motion. So that means we have to consider this pseudo force also. Yes, now in the frame of the bigger block, okay, in the frame of that bigger block, okay, mass M, okay, in that frame we are observing things. Okay, suppose it has acceleration say A0, that is the acceleration in this direction. Okay, so that is for the bigger block. Now what you do, we will consider both the blocks. Now first of all, let us find this acceleration. How to find it? See, let us consider this system M plus M. For this system M plus M together, what is the total force in the horizontal direction? That is F. So F is the only force in the horizontal direction. That must be equal to mass times the acceleration, but mass is M plus M multiplied by the acceleration is taken as A0. So this gives you the required acceleration A0 of the blocks in the horizontal direction, F divided by M plus M. So that is the acceleration of the observer, because observer is on the bigger block. That means its acceleration is this. This is the acceleration of the observer. So pseudo force is mass times this acceleration. Okay, done. Now for the smaller block. Okay, now for this M plus M in the, okay, so now we will consider the smaller block. What are the forces acting on the smaller block in the frame of reference of the bigger block? Alright, so for the smaller block, what are the forces acting on the block? Now the normal force between these two blocks, right? Normal force is what is pushing this. So normal force, so that is N. So N is the normal force between these two blocks. Okay, yes. Now also the pseudo force, right? Because this block, okay, the observer is moving in this direction, so there must be some pseudo force in the opposite direction. What is the pseudo force? Minus mass times the acceleration, ma0. Okay, ma0. So that is the pseudo force, n minus. This is the total force acting in the horizontal direction. That must be equal to 0, because with respect to that bigger block, the smaller block is at rest in the horizontal direction. Okay, done. So this is for the horizontal direction. Now for the vertical direction, what are the forces acting in the vertical direction? See, the gravitational force in the downward direction, mg, against which we have the frictional force between these two blocks, right? Frictional force. What is the frictional force formula? Mu multiplied by, so that is mu multiplied by the normal. Okay, normal between the two blocks, mu multiplied by the normal. So that equals 0 because this block is not sliding down. So that means it is in equilibrium in the vertical direction. Okay, so this is the frictional force between the two blocks. Okay, so that's all. But this normal is already known. What is this normal? M multiplied by A0. So that can be substituted there. So this gives you our required value. So mg minus mu multiplied by this normal is MA0. So that equals 0. But this A0 is already found here. So F divided by M plus M. So that means, so this M gets cancelled. Okay, so G minus mu A0. But A0 is F divided by M plus M. So that equals 0. So that's all. This will give you our required force F. So that equals, alright, so G multiplied by M plus M divided by mu. So that's all. So that is the required answer. Alright, so simple. See, the normal force. Normal force is what is making that smaller block move. But we are not considering the acceleration. See, even without using pseudo force, we can do this. Right? See, if you don't use the idea of pseudo force, what will happen? The only force acting on the smaller block is the normal force. So that normal force equal to mass times the acceleration. But mass times acceleration. So n equals mass times acceleration. But what is the acceleration of the smaller block in the horizontal direction? That is same as the acceleration of the bigger block because they move together. So total force in the horizontal direction, that is n only, equals mass times acceleration. That's all. Okay. But now we are in the frame of that bigger block. That means this smaller block is not moving in the horizontal direction with respect to that block. So that means the total force is not only n but also the pseudo force. So that must be equal to 0. Alright. So even if you don't use the idea of pseudo force here in this case, here, so still it is okay, right? We can simply use the direct formula, total force equal to mass times the acceleration. Alright. So that's all. So anyway, so this is a required force, G multiplied by M plus M divided by mu. Okay. This is similar to the last question, but two blocks are there which are connected by a string. So we have to find the minimum and maximum force F for these two blocks to be in equilibrium with respect to that bigger block. Okay. See, here we are not finding the exact force F. We have to find the range, right? Minimum and maximum. In the last question, it is the exact force, right? So for that force, it will be in equilibrium. Less or more, the object will slide. But here it is not the case. So there is a minimum and maximum. The F can lie within that range for the system to be in equilibrium. See, if you apply minimum force, what will happen? Not enough force. So then the block B will slide down. It will move in the downward direction. That means the block A will move in this direction, forward direction. Okay. Now if you apply maximum force, more than what is required, what will happen? This block A will move in this direction, right? It will have the tendency to slide backwards. That means the block B will move upward. So if you apply more force, B will move downwards. Right, B will move upwards, A will move to the left. But if you apply minimum force, which means not enough force, block B will slide down and this block A will move in the forward direction. Do you understand? So now if F lies within that range, then these objects will be in equilibrium. So we have to find both minimum and maximum force. Alright. See, similar questions we have already done in friction, right? So direction of friction. So when you discuss the direction of friction, you consider all this minimum and maximum, right? Range of the force F for equilibrium. Okay, now let us consider this system in the frame of reference of that bigger block of mass capital M. Okay, yes. First of all, let us find the acceleration of that block. So this system for the two blocks, okay, for the blocks A and B, okay, plus that capital M, okay. So let us consider all these together. What are the forces? What is the force acting in the horizontal direction? That is only the force F, right, for the whole system. So that equals mass times the acceleration. What is the mass? So that is M plus M. So 2M plus mass of the bigger block M multiplied by the acceleration is taken as A0. Okay. So that means the acceleration of the bigger block, so that is F divided by 2M plus M. So that is the acceleration of the observer, right? The observer is now in the frame of that bigger block only. Okay. In the frame of M. Okay. We are considering in the frame of that capital M. Okay, that means it is the observer is moving with some acceleration, so we have to consider pseudo force also. But see, now we have to find minimum and maximum force. Let us first find the minimum force. Okay, minimum for F minimum. See, why we are finding separately minimum maximum, the direction of friction will be different. Okay, in these two cases, suppose you apply minimum force only. If you apply minimum force, then this block B has the tendency to slide down. It will try to move downwards, right? You not enough force F, so the block B will slide down, right? That means the block A will move in the forward direction, this direction. So if it has the tendency, it tends to move in this direction, what is the direction of friction? In the opposite direction, right? So if it tries to move in, it is not moving, it is not sliding, it is in equilibrium, but still it has a tendency, it tends to move in this direction because we are applying only minimum force. That means friction force will be in the opposite direction. Okay, so friction is in the opposite direction. Now let us write for the block A. What are the forces acting on the block A? So the tension force, yes, T in this direction, and also the pseudo force, right, or the frictional force in the opposite, frictional force in the opposite direction. See, direction is important because otherwise you will get the maximum force, right? So T, friction is in this direction, opposite direction. So minus, what is the formula for friction? So mu multiplied by the normal is mg only, okay, mg, right? Normal is balanced by that gravitational force, and also the pseudo force, because the observer, that is the bigger M, right, that is moving in this direction, there will be pseudo force in the opposite direction. So what is that? That is mass multiplied by the acceleration of the observer. That is what we have taken as A0. This is a total force that must be equal to 0, because with respect to the bigger block, this block A is in equilibrium. Okay, done. So that is for the block A. Now similarly for block B, what are the forces acting on this block B? Okay, so let us find it in the horizontal direction. Okay, what are the forces acting in the horizontal direction? So that is, only force is the normal force. Okay, normal force in the horizontal direction, normal force. Okay, this normal is between the bigger block and that block B. Okay, now we have to consider the pseudo force also, because the block is moving, the observer is moving in this direction, the pseudo force will be in the opposite direction. So minus M, same M only, so A0, so that equal to 0. Okay, so that will give you the normal force. Okay, now the same block B, we have to consider the vertical motion also. What are the forces in the vertical direction? Now mg in the downward direction, minus tension in the upward direction, tension is acting in the upward direction, and also the frictional force in the upward direction. See, again, direction of friction, this block B tries to move in the downward direction, because minimum force, the block B will try to move in the downward direction, so friction will be acting against it. So friction is in the upward direction, that means minus frictional force. But what is frictional force? That is mu multiplied by the normal. Okay, that must be equal to 0, equilibrium. Okay, so that's how this normal can be substituted here, and then this T can be, so we can alright, we can substitute here and then add to eliminate this T. So this implies, okay, mg minus T. This T can be substituted from this. So T is mu mg plus minus ma0. Alright, so we are adding this. So minus mu n. So that is minus mu. But n we have already found. So what is the value of n? ma0. So mu ma0, so this must be equal to 0. So we can divide m here, so divide by m. Okay, so we want a0. all right, so that gives you our required a0. So that equals, so you can take g out, so it will become 1 minus mu divided by this one. So here m is divided, so a0 is taken common, 1 plus mu. Okay, so 1 plus mu. So that's also, this is the value of a0, that is the acceleration of that block, bigger block. Okay, but we want the force, right? So what is force here? So we can substitute this a0 here. What is a0? F divided by 2m plus m. Or we want the force is a0 multiplied by 2m plus m. So directly we can write, so this implies our required force F. But that force is the minimum force, right? So F minimum equal to a0 multiplied by 2m plus this thing. So it is g multiplied by 1 minus m divided by 1 plus mu multiplied by, so 2m plus m. So that's all, that is the minimum force. Okay, so that is the answer. But we also need to find the maximum force. For maximum force, so if you apply maximum force, so we have to do the same calculation again with the friction in the opposite direction. So if you apply maximum force, the block A will try to slip in the backward direction. So if you apply maximum force, that block will try to slip in the backward direction. So friction is in the forward direction. When you say minimum force, that is the other way around. But here, when you apply maximum force, the friction direction changes. Rest of the things same, right? Friction has a different direction, opposite direction. Okay. So do we have to do all these calculations? We have done similar question in friction. If you remember, if you want a minimum from the maximum, you simply change the direction of friction. So what you do, simple, you replace this mu by minus mu. That's all. Okay. Otherwise, everything else is same. Only here instead of minus mu mg, we are plus mu mg. So here also plus mu. So here the only change is mu is replaced by minus mu. That's all. So that will give you F maximum. So that will give you F max equals, so everything else same, so mu becomes minus u, it will minus mu, 1 plus mu divided by 1 minus mu, so this is same, 2m plus mu. That's all. So this is the minimum and the maximum force. Is that okay? Yes. Now, so minimum, maximum we are finding separately, okay, because there is some range within which F lies, then the object will be in equilibrium, not exact amount of force. It can lie within that range. If it exceeds, it will slip in one direction. If it is less than that range, then it will move in the other direction. To prevent that, the force must be lying within that range. Okay, so minimum is found. Here we find the maximum. Okay, F max. For F max, you simply do this instead of doing the calculations all over again. Okay, so that's all. So this is the answer. Here a block is placed over a wedge and these things are connected by a string. See, this is a question of constrained motion, right? We have to first find the relation between the accelerations of these two objects, right? Yes. Now, you see, this wedge will move only in the horizontal direction, right? So this, suppose it moves in this direction, that block will move in the downward direction, but it has acceleration in two different directions. Remember, so one thing is, if the wedge moves in the horizontal direction, this block will also move in the horizontal direction because they are always in contact. It will move in the horizontal direction. So it has one component of acceleration in the horizontal direction, block. Now it will also move down that incline, right? It will move down the incline, which means it has one acceleration component in this direction and one acceleration component and along that incline. So we have to take the resultant. Okay, yes, but the horizontal component of the acceleration of the block is same as the horizontal component of acceleration of the wedge. Wedge moves in this direction, the block will also move in this direction. So same horizontal component. But what about the acceleration along the incline? Okay, what is the relation between them? That we have to find. Okay, so for that we have done many methods of constrained motion, right? We've done some 3 or 4 methods. See, one method is this displacement method. Suppose this wedge moves by distance x. What is the distance that one moves? The block moves. Okay, yes, let us see. Suppose it moves by distance x. That means the string x plus x, so 2x part of the string should be compensated by that block. Alright, so x plus x2, so two strings are connected, x plus x is 2x. So that means that 2x part is compensated by the block by that block is moving in the downward direction, moving along that incline by distance 2x. That means when the wedge moves by distance x units, the block moves by distance 2x units, which means the acceleration is twice. The acceleration of the block is twice the acceleration of the wedge. See, we can also use that tension method. Okay, what is the tension method? What is the tension acting on the wedge? So that is T plus T2T, right? Two strings, T plus T2T. What is the tension acting on that block? So that is just T. That means, so we know this method, right? So 2T multiplied by acceleration of that block of mass m, right, the wedge. So that plus T multiplied by acceleration of m, that must be equal to 0, right? Because we know that tension method, right? Tension multiplied by acceleration, the sum of all such values. So that is, so now you multiply. So this gives you the acceleration of the block of mass small m, that equals 2 times the acceleration of the wedge. So that is the relation. So that relation can be found directly also. If this moves by distance x, so the other one moves down by distance 2x. This is not the acceleration of the block. It is the acceleration component of the block along the incline. But in addition to this, it also has some acceleration in the horizontal direction. We'll do that later. But now, at least along that inclined plane, that block has acceleration 2 times the acceleration of that wedge. Okay, so that is one relation. Now let us do it one by one. Okay, so first of all, so we got this relation. Now, so let us consider all the forces acting on that wedge. Okay, so that wedge. What are the forces acting on the wedge? Right, T plus T, right, T, 2T. Okay, 2T. Alright, two strings are connected, T plus T. Not only that, there is a string in this direction also, but that is inclined, that is not horizontal. So we have to take its component. What is that? T cos theta, alternate angle, right? Cos theta, T cos theta. So minus, opposite direction, minus T cos theta. This is the total force due to that string. Okay, now we have the normal force due to that block. There is a normal force between the wedge and the block, right? Normal force. So that normal will also contribute in the horizontal motion of the wedge. So what is its component? So that normal is in this direction. Okay, now we take its component in the horizontal direction. That will be n sin theta, right? Sin theta, 90 minus n sin theta. So that is in the forward direction. So plus n sin theta. N sin. This is the total force acting on this wedge in the horizontal direction. So that must be equal to mass times, so mass of the object. So mass times the acceleration. So mass times m. Okay, that's all. This is for that wedge. Okay, but let us simplify this. We know the value of theta, right? 60 degrees, and then substitute that. Substitute theta 60 degree. Okay, so this is 2t minus t by 2, right? Cos 60 plus n sin 60. So that is root 3 by 2. That equals, so mass of the wedge, so that is also known, that is 8 kilogram multiplied by acceleration of this. So this is simplify this further, so it is 4t minus t, 3t plus root 3n equals 16 multiplied by m. Okay, that's all. This is equation number 1. Okay, so one equation we found. Okay, now similarly for the block, now block in the normal direction. First of all, we will find the normal direction. Okay, in the normal direction. So what are the forces acting in the normal direction? Of course, n is acting in that direction, n in the normal direction. The force between these two, the normal force between these two objects, and also mg in the downward direction. So mg cos theta, right? You take the component in the normal direction, mg cos theta. So minus, opposite direction. So minus mg cos theta. Is there any other force acting on this? See, now we have to find, we are finding this equation, we are writing the equation in the frame of reference of that wedge only. Okay, so we are in the frame of wedge. Okay, we are not observing from outside, right? If you are in the wedge, so now we have to use the concept of pseudo force also here, because we are in the wedge. That means we are observing, okay, in the frame of the wedge. So that means pseudo force also there, because we are in the accelerated frame of reference. So the wedge is moving in this direction. That means there will be pseudo force in the opposite direction. Wedge is moving in this direction with acceleration am. That means there is a pseudo force in this direction. What is that pseudo force? So that is plus mass of the object, mass of the block multiplied by the acceleration of the observer. Acceleration of the observer is am. But not this, right? It is only in the horizontal direction. We have to take its component. Okay, 90 minus theta. So that means am sin theta. Okay, in the normal direction. So that's all. This is the total force acting on this block in the normal direction. But that must be equal to 0, right? Because in the normal direction, the object is not moving. In the frame of the wedge, if you observe from outside, there is a motion in the normal direction also. If you observe from wedge, then there is no normal motion of that block. Okay, so that's it. Okay, now let us simplify again. So substitute the value of theta. Theta is again 60 degrees. So substitute. So this is the pseudo force. So remember, this is the pseudo force. Okay, yes. So that's all. So what is this value? N minus. So this is m. That is 4. No? 4 multiplied by g is taken as 10. Cos 60. That is 1 by 2 plus m is 4. Am, we can keep it as it is, am sin theta, sin 60 root 3 by 2 equals 0. So this gives you some relation. So what is that? So n minus 20 this is okay, 2 root 3 plus 2 root 3 am equals 0. That's all. So this is equation number 2. Okay, so we've got two equations. Now we have to write the equation for the same block only, but along the inclined plane now. Okay, this is in the normal direction, now along the inclined plane. So the block now along the incline. Okay, yes. Now what are the forces acting on the block? The tension is acting in the upward direction, right? So it is moving in the downward direction. So gravitational force in the vertically downward direction, you have to take its component. So mg cos theta, right? Mg sin theta, sorry. So mg sin theta along the inclined plane, right? Mg sin theta. And next, what are the other forces acting on this? So tension is acting in the opposite direction, minus T. Okay, tension is acting in the opposite direction. And also we have that the pseudo force, but you have to take the component of the pseudo force in the direction of the incline. The pseudo force is same thing, M, AM, that is pseudo force, but you have to take its component in the horizontal direction. So what is that? So that is yeah, plus downward direction. So plus AM multiplied by what is that angle? So that angle is theta, right? So cos theta. This is the total force acting on the block M in along the incline. Now that must be equal to mass times the acceleration. So what is the mass of the object? So that is M multiplied by the acceleration of the object. Acceleration of the object is AM, but this AM is known, right? What is this AM? That is 2 times A capital M, right? That can also be substituted here. So, but let us simplify this. But we know the value of this. This is M is 4, 10, and sin 30 is sin 60 root 3 by 2 minus T plus 4, okay, AM. 4 AM cos theta. Cos theta is 1 by 2. So that equals this M, this AM can be 2 times capital M, right? So this M is 4 multiplied by 2, so that is 8 multiplied by A capital M. So this will give you one equation. So that is, so what is that? It is 20 root 3, okay, minus T, yeah, so this is 2, so that equals 6 AM. Okay, that is equation number 3. So we have got 3 equations and 3 values to be found. What are the unknown values here? T, AM and normal, okay, N. So these are the 3 values. You can eliminate this N and T. How to do that? So we can find N from this and substitute here. Find N from this, substitute it here. Now similarly T can also be substituted, right? So T can be substituted here. So you find N from this, substitute here, and T can be substituted here, and we will get AM, right? I'm not doing the calculation, so already it's going no. So this is a very long question, so it requires a lot of calculations. Okay, so T is found here from here and N is found from here, that is substituted here, and if you do that substitution we will get the answer. Okay, I'm writing the answer directly. Okay, the calculation is left for you. Okay, the acceleration of AM, so that equal to, so 2 root 3, okay, yeah, 2 root 3. Okay, this calculation is for you to do. Okay, so 2 root 3, so that is AM, but that is not the answer, that is not the acceleration we want the acceleration of the block. But this is the acceleration of the wedge, but that is same as the acceleration of that block in the horizontal direction. Okay, so that is same. So that means this block has horizontal acceleration 2 root 3. Okay, now it also has acceleration component along the inclined plane, right? Along the inclined plane also it has acceleration, but that is 2 times the acceleration of AM. That means it is 4 root 3. And the angle between these two is 120, right? 60 degree, 90 plus, okay? So 180 minus 60 is 120 degree. If 2 vectors are known, we can find the resultant of that vector, right? So we have the formula, right? So what is the formula? The resultant, the acceleration of that block is equal to square root of, okay, this square plus this square. So what is the square of this? So 4 root 3 square. Or we can take it as AM, and this is 2 AM. So that is AM square plus 2 AM the whole square plus 2 AM multiplied by cos of 120 degree. Okay, hope you remember this formula, right? So 2 vectors are known, we want to find the resultant, like a square plus b square plus 2ab cos of the angle between them, square root of that is the resultant. So now AM is this and 2am is this, so simply substitute, you will get a required answer. So AM multiplied by, so root yeah, so 120 minus, okay, root 3, am root 3, but am is already known, 2 root 3, so that means this value is 2 root 3 multiplied by root 3, so that is 6. So this is the required acceleration of the block. Okay, so 6 is the required acceleration. Okay, so a lot of calculations are there, but it's a simple, one by one you consider, right? So there are calculations, but the concept is very simple. You have to find for each of these objects. First, for the wedge, we write the equation. Wedge is moving in the horizontal direction. You write all the equation in the horizontal direction, considering all the forces. But for the block, now we are in the frame of the wedge. So we are in the wedge frame. That means you have to consider the pseudo force also. Okay, along with the other forces. Okay, in two directions, one in the normal direction, one along the incline. Okay, rest of the things is simply solving the equations to get our required acceleration. Okay, so that's all. So 6 is the total acceleration of that block. Okay, so that is the answer. Here a man is moving on a plank which is placed on a smooth surface. There is no friction between this plank and the ground. Now there is friction between the man and the plank. So it is the frictional force that is making this man move in the forward direction. Because of the same friction, this plank will move in the opposite direction, right? Now the acceleration of the man is A with respect to the plank. That is not the actual acceleration of the man. With respect to the plank, the acceleration is A. Okay, yes. Now what do you do? We will observe this in the frame of reference of that plank only. Okay, in the plank frame. In the plank frame. So the plank is moving with some acceleration, say A, okay, AP. AP is the acceleration of the plank in this direction, right? Because man is moving in this direction, he is pushing the plank in the opposite direction. Okay, yes. Now that is the acceleration of the observer. Now what are the forces acting on the man now? Okay, so what are the forces acting on the man? It is the frictional force between him and the plank. So that is the frictional force in the forward direction. Okay, in the frictional force. Okay, and we also have that pseudo force because we are observing from that accelerating frame. So what is the pseudo force? Mass of the man. The observer is moving in the opposite direction. So frictional force, sorry, the pseudo force is in this direction. So that means plus only. Plus mass of the man multiplied by the acceleration of the observer, that is AP. That equals the acceleration of the man with respect to the plank. That's what is given in the question. So that is the mass of the man multiplied by the acceleration of the man. This is not the actual acceleration of the man. It is only with respect to the plank. With respect to the plank only we need, because this is only from the frame of the plank. That means this is the acceleration with reference to that plank only. So that means this is correct. Okay, so that is for the man. Similarly for that plank, what are the forces acting on that plank? What are the forces acting on that plank? It is the frictional force between him and that plank that is making it move in this direction. So only frictional force, that's all. So frictional force, that equals mass times the acceleration. So the mass of the object is okay, so that is m. The acceleration, that's what we have already taken to be, say, AP. So that's all. These are the two equations. Solve them, we get our required answer, right? So F can be substituted here. So this implies, so what is F here? So if you substitute here in this first equation, we are getting m multiplied by AP. So we get m plus m multiplied by AP. So that equals, so m multiplied by the acceleration. So that gives you the acceleration of the plank. So that equals m divided by m plus m multiplied by a. So that is the acceleration of the plank. Okay, done. Now what is the acceleration of the man now? So the acceleration of the man, not A is the acceleration with respect to the plank. Now we need the acceleration or the actual acceleration of the man. So that is same as the acceleration with respect to that plank. Okay, now this plank is moving in the opposite direction. That means, so due to that plank, he will have acceleration in the opposite direction, right? Because this is only the relative acceleration. So that means the acceleration of the man. So we can write it as say A m, something like this, am. So that equal to the acceleration related to that plank, okay, related to the plank minus the acceleration of the plank itself, minus the acceleration of the plank, okay, because plank is also moving in this direction, so that will drag that man also along with it. So the acceleration with respect to the plank minus the acceleration of the plank, that's all. So we have already found AP, so that can be substituted here. So if you do that, what do you get? A minus this value. So what do you get? So 1 minus m divided by m. So that will give you the required answer, m, capital M divided by m plus m multiplied by a. So that's all. So this is the acceleration of the man, okay. So that's all. So this acceleration of the plank, see, because the acceleration with respect to the plank is already given, so you better do this question in the frame of reference of the plank itself, so that we can use this A directly, okay. With respect to the plank, so we have a pseudo force also, total force equal to mass times the acceleration with respect to the plank, okay. So similarly, the other equation, just solving, we get the required answer. So this is the acceleration of the man, this is the acceleration of the plank, okay. That's about pseudo force. In the next class, we'll do centripetal force, okay.